Good morning. This is Module 5, Lesson 10, and we're going to continue our work that we started yesterday using division to find equivalent fractions. There are a couple of things that you will need to know and that we're going to draw on in this lesson that we maybe have not used in a while. One of those things is that we're going to be using factors. So I want you to remember what factors are. Factors are the numbers that you multiply together to equal another number. And so, for instance, if I were to ask you what are the factors of 8, then you would say, well, 1 times 8, so 1 and 8 are factors. And then we also know that 2 times 4 equals 8, so 2 and 4 would be factors. So the factors of 8 would be 1, 2, 4, and 8. We are going to use those factors because we're going to try and find common factors, or factors that both our numerator and denominator have in order to solve some of these problems. We'll still use area model, but we're going to be moving towards using factors more instead. So let's get started. Remember today that when it comes time to do a problem, you pause the video, you do the problem on your own, and then you come back on to check and see if you have the same answer that I have. We will start with our I can statement, counting down from 3, and I want you to say it and read it with me. 3, 2, 1. I can use the area model and division to show the equivalence of 2 fractions. So this is just the same as what we did yesterday. We're just continuing the work and taking it a little bit deeper. Alrighty, we're going to start with some fluency things, and we're going to count by equivalent fractions. So what we're doing is we're counting by 3s to 24. 3 fourths to 24 fourths. Okay, so we're going to start at 0, 0 fourths. You can see the numbers here, so let's go. 0 fourths, 3 fourths, 6 fourths, 9 fourths, 12 fourths, 15 fourths, 18 fourths, 21 fourths, 24 fourths. So we were just counting by 3, but then we were adding the fourth in our denominator to make that happen. As you do that, we've got 3 fourths, 6 fourths, 9 fourths. We come to 12 fourths. And 12 happens to have the same 4 is a factor of 12. So if we look at how many times does 4 go into 12, well, it goes in 3 times. So we have a whole number here of 3 fourths. The next time we have a number that 4 is a factor of is when we get to 24 fourths. And 4 goes into 24 6 times. So the next time we count, we're going to replace those numbers with those whole numbers that we just talked about. So let's start again. We'll start at 0 because we don't need to say 0 fourths. 0, 3 fourths, 6 fourths, 9 fourths, 3, 15 fourths, 18 fourths, 21 fourths, and 6. So this is just a way of just helping you see that we can use a fraction to represent a whole number, and there are different ways that we can do that. Alrighty, we've done this before. We're going to practice this. Say the fraction and complete the number sentence. So I want you to go ahead and pause the video right now, see if you can complete this on your own, and then come back. Alrighty, we're going to start with 3 fourths, and because we started with 3 fourths, I am going to write that in right away. 3 fourths times something. Well, I've got on my denominator, I see that 4 times something has to equal 8. And I know that 4 times 2 equals 8, so I need to multiply by 2 in the numerator as well. So 3 times 2 equals 6. So I know that 3 fourths and 6 eighths are equivalent fractions. I'm going to practice this again. Same thing. Go ahead and shut your, pause your video. Do this on your own and then come back. All right, we're going to start with 3 fourths again because that's the fraction that we have here. So we're going to go ahead and put that in. Now I see that in the numerator I need to multiply 3 times something to equal 9. Well, I know that 3 times 3 equals 9. Do the same to the top as you do to the bottom, or the bottom as you do to the top. and 4 times 3 is 12. Therefore, I know that 9/12 and 3/4 are equivalent fractions. Okay, same thing. Pause your video. Alrighty. Start with 2/5, just like we always do. We start with our fraction that we've got here. I see that on the top, 2 times something is 4, so I multiply 2 times 2, and I know that equals 4. Got to do the same thing there in the denominator. 5 times 2 is 10. So I know that 4/10, 2/5 are equivalent fractions. All right, another practice. This is really good for you to just practice this and get really fluent at it. After you've paused, come back. And we start with 3/5. And on the denominator, where in the denominator we see we need to equal 15. Well, I know that 5 times 3 is 15. If I multiply my denominator by 3, I have to multiply my numerator by 3. So 3 times 3 is 9. And there we've got 3/5 is equivalent to 9/15. Now we're going to do the same thing, except in a way we're going to do it backwards. So we've got a model. We're going to write the fraction that is shaded, and we're going to compose that into larger units, which we did before. So we started off with 2/4, and you can see that we've got 1, 2, 3, 4. That gives us our denominator, and 1, 2 of those parts are shaded, which gives us our numerator. So once again, when I do my division, my sentence here, I'm going to start with the same thing I started with. Now I'm going to take this and I'm going to compose it into 2 parts instead of 4 parts. And since I've divided it by 2, I need to do that to the top and the bottom, because now, as you see, instead of having 4 parts, I just have 2 parts. So 4 divided by 2 is 2. 2 divided by 2 is 1. This one is pretty straightforward. We've seen it in a lot of different forms, but there we have it. That 2/4 is equivalent to 1/2. Let's try the same thing here. We're going to start again with 3/9. This is a good place for you to pause. Do it on your own if you can, and then come back and see if we agree. All right, I'm going to start with my 3/9 because that's what I have right here. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9 parts, which is why my denominator is 9. I have 1, 2, 3 of those parts shaded, which is why my numerator is 3. So 9 parts altogether, 3 of them are shaded. I'm going to go ahead and compose that into larger units. So I can see right away that if I do it into groups of 3, I can create a different thing here. And so now I have 3 parts, which means my denominator has to be 3. So 9 divided by 3 gives me 3. Do the same thing to the top. 3 divided by 3 is 1. So here I have 3/9 equivalent to 1/3. And I did that by combining some of those units. Same thing, here we go again, 4/12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 gives me my denominator, and 1, 2, 3, 4 gives me my numerator. So pause, you solve this if you can on your own, come back. We started with 4/12, so that's what I'm going to start with here. I see that if I can put 4 units together, it's really easy to see that when we draw this model, right? So I can put 4 units together. Well, there are 4 in each unit, so I'm going to divide by that 4. And right now I can see, oh, now I have 3 units. 12 divided by 4 equals 3. And 4 divided by 4 is 1, and I can see that that is accurate with what I've drawn here. So 4/12 is equivalent to 1/3. So we're basically doing the same thing as we were doing when we were finding equivalency by multiplication, except we're kind of working backwards. We're starting with our fraction that we're going to make smaller, or actually larger, to do this. All right, we are to our application problem. So Nuri spent 9/12 of his money on a book and the rest of his money on a pencil. So we have to A, express how much of his money he spent on the pencil in fourths, not twelfths, which is what we started with. And then B, Nuri started with $1. How much did he spend on the pencil? So let's see what we've got. We're going to start with a model here. And I might be erasing it in a minute, but we're going to start with it so that we can just draw this out and see what we've got. All right? I feel like I've been drawing a lot of twelfths lately. So we start off with 12 parts. And if he spent 9 twelfths, 1, 2, 3, 4, 5, 6, 7, 8, 9, he spent this much on a book. Okay? Well, what's left? I've got how much left? This is our pencil. And if we take out of 12, well, he's got 3 twelfths left that he spent on his pencil. Now they're asking me though, they're saying, hey, well, how much of his money did he spend on the pencil in fourths? Oh, in fourths. Well, so I need to divide, or rather compose this into fourths. So my pencil, I've got right here, and I've got that there are 3 of those. So let's see if we can compose this into parts made up of 3. So here's one part. There's 3 of those. Let's go to the next 3, the next 3, and the next 3. And 1, 2, 3, 4. I've got 4 parts, so that looks like that worked. So if I've got 4 parts, how many of those 4 parts did he spend on his pencil? Well, you can see that we divided by 3. 12 divided by 3 is 4, and 3 divided by 3 is 1. So he spent 1/4 of his money on the pencil. They're also asking us though, okay, they said he started with $1, and how much did he spend on the pencil? So for me, whenever I think of a dollar and I think of fourths, well, I think 4 quarters is equal to $1, right? So 4 quarters equals $1. So of those 4 quarters, if he spent one of those quarters on the pencil, because 1/4 of it, then the pencil was 25 cents, because he spent 1/4 or 1/4 of his money on the pencil. If you didn't quite get all of that, I want you to stop. I want you to go back on the video, play it again so that you can understand how we arrived at these answers. All right, let's move on. We are going to, write in expanded form. I love expanded form. So what that means is expanded form is when we separate out each part and add them together. So I'm going to start right here with my 4, and I've got 4 million. So I'm going to start with 4 million. Got to write 4 million. One way to think of that is you do the 4, everything else becomes a 0. Then I'm going to go to the 5. I'm going to write my 500,000. Everything else after it becomes a 0. So 4 million plus 500,000. My 9. Write down my 9. Everything following it becomes a 0. So, whoops, I just put that in the wrong place. I put my comma in the wrong place. Let me just do that again. So my 9, I have my 9, and then I've got a 0, 0, 0, 0. So 90,000. My 2 is 2,000. So I'm going to write 2,000. 0, I don't have to write anything because it's a 0. I don't need to put anything there. So then I'm going to move to the 1. So the 1 is a 10, and it's followed by one number, so I'll put 1, 0. And then finally my last number is 2. So 4,592,012. Expanded form is 4 million plus 500,000 plus 90,000 plus 2,000 plus 10 plus 2. Alrighty, here's another good review that I think all need practice in. We're going to round 9,382,921 to the nearest 100,000. So I'm going to find what's in that place, and the 100,000th place is a 3. So I'm going to have to, that's what the number I'm going to be rounding to. The number I look at is the number just to the right of it. And that 8 is going to tell me, what am I going to do to the 3? Does 3 stay the same, or does 3 go up? So I look at that 8 is 5 or more, so it is more than 5. So that tells me that my 3 is going to go up. So I'm going to write my 9 because it's not changing, because it is to the left of my 100,000s. But my 3 is going to change into a 4 because the 8 tells us that. So that's going to become a 4. Everything else after the 3 becomes a 0. So if I round 9,382,921 to the nearest 100,000, then my answer becomes 9,400,000. This is something we can use a lot of practice in, and we'll hopefully get more and more of that as we go. All right, here we go. This is into the lesson, and we want to draw a model that represents 10 twelfths. And if you look at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, we've got 12 parts, and we have 10 shaded. So if we want to compose an equivalent fraction, well, what do we do? So this doesn't fall so evenly as our other pictures did. So we have to think of it. And they ask the question, first of all, what's the largest common factor of 10 and 12? So this is where I talked about that we're going to be looking at factors. So let's look at our factors of 10. 1 is a factor. 10 is a factor. We know that because 1 times 10. I know that because it ends in a 0, so I know it ends in an even number, that 2 is going to be a factor. And I know that 2 times 5 is 10. So here are my factors of 10. 1, 2, 5, and 10. So now I'm going to look at my factors of 12. Well, again, I know 1 is a factor. I know 12 is a factor because I know that 1 times 12 is 12. So those are factors. I know that 2 is a factor because it ends in an even number. So I know that 2 times 6, those are factors. I also know that 3 is a factor because I know that 3 times 4 equals 12. So my factors of 12 are 1, 2, 3, 4, 6, and 12. Now, as I look at these, they're asking what's the largest common factor. In other words, what is the largest number that both of these have as a factor? Well, as I'm looking, the only common factor that I see is 2. So that's going to be my largest common factor. Because I know that's a factor, that tells me I can decompose or compose these into groups of 2. And now, as I do that, how many groups of 2 do I have? Well, I have 1, 2, 3, 4, 5, 6. So I have 6 groups of 2. That tells me that's going to be the denominator of my new group. I have 1, 2, 3, 4, 5 of those groups are shaded. So I know that 10 twelfths an equivalent fraction for 10 twelfths is 5 6. And if I were going to do that with a division problem, which we have been doing with all of our problems, well, what did we do? We divided by 2. We moved them into groups of 2. So 10 divided by 2 is 5. 12 divided by 2 is 6. Okay, look at that next one. We're going to draw a model. This says that 6/10 is equal to 3/5. So we want to prove this. And I want to use a model, and we also want to think about factors and just using our other way of, I'm sorry, I'm kind of getting, we want to do this by factors and also by using our model and using our division sentence. All right, we have 10 parts, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'd like you to draw those on your paper and have those on your paper. And then I want you to shade in 6 of those parts. So I'm shading in 1, 2, 3, 4, 5, 6. I've shaded in 6 parts. So hopefully you've done the same. And then we've got to figure out, we want to get from 6/10 to 3/5. Well, what can we group? How can we group these? How can we change our unit size instead of being the size they are right now. 1, how can we change them? I know that because these are both even numbers, 6 and 10 are both even numbers, then I know that 2 goes into both of them. And so I'm going to go ahead and I'm going to turn them into groups of 2. I'm going to group 2 together. Well, actually, I'm going to do this a little bit differently. Let me, just because I realize that's not going to work as well. So let's kind of fix that. All right. I'm going to group 2 of these together. So I'm going to group these 2 together. And then I'm going to group these 2 together and these 2 together. And then 2 and then 2. Doesn't always work out that we can do it all evenly. And so this will work. So now I have 1, 2, 3, 4, 5 groups of 2, which is my denominator. And I'm going to write this in here. Because I divided them and I made them into groups of 2, then I'm going to divide by 2. And now I have 3 groups that are shaded. So I have 3 groups of 5 now. So I divided both by 2 because if you do the top, you have to do the bottom. And now I've got 3/5. Alrighty, I know this is a lot, and just practicing. That's what we're going to try and do. So draw an area model to represent 8/12. Let's see. I think this time I'm going to do my 12ths like this. And I have got 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 12 there, and I'm going to color in 8 of those. 1, 2, 3, 4, 5, 6, 7, 8. I'm doing this slightly different than I've done it before because I want to just show you that there's more than one way to show how we do this. All right, well now I've got to think, how many parts should I divide it into? So I'm going to go back to my factors. My factors of 8 are 1, 2, 4, and 8. And you remember that because we did that just a few slides ago. And I know that my factors of 12 are 1 times 12, 2 times 6, 3 times 4. I'm going to get my 6 and my 12 in there. So I'm going to look at my factors. Here's my factors for 8, my factors for 12. And as I'm looking at them, I can see that they both have a 2. They also both have a 4, and 4 is larger. So I'm going to I'm going to compose my model into groups of 4. So I've got 1, 2, 3, 4. I'm going to put those together. 1, 2, 3, 4. I'm going to put those together. And 1, 2, 3, 4, I'm going to put those together. Now, because I put it together in groups of 4, then I can say, well, 8, I've started with 8/12, right? So I'm trying to find my new equivalent fraction, and I put them into groups of 4. So I divided by 4. And so 8 divided by 4 is 2. 12 divided by 4 is 3. So I'm dividing by the number that I put into a group. So now if I look at this, I can see I've got 1, 2, and 3 groups with 2 of those shaded. And that does match what I said here with 2/3. Again, all of these, if you have questions, stop the video, go back and replay it, and see if you make some sense of it. Alrighty, now we're supposed to reduce 8/12 to simplest form without using an area model. Well, guess what? We already know how to do that because we just did that. So how do we do it? The first thing we need to do is find the largest or the greatest common factor. So that's what we're going to look for. We're going to look to find the greatest common factor of 8 and 12. So we look at 8, and we know, again, our factors for 8 are 1, 2, 4, and 8. We have to find our factors for 12. You already know always that 1 and 12, 1 times the number that you're multiplying, are factors. I know that 2 is a factor because I know that 2 times 6 is 12. I also know that 3 times 4 is 12. So these are my factors of 12. 1, 2, 3, 4, 6, 12. I look at them. As I look at them and they're lined up, I can see, oh, look, 2 is a factor of both of them. But I'm going to look a little further, and oh, 4 is also a factor. 4 is my largest factor that both of them have. Both 8 and 12 have 4, which means, just what we did before, I am going to take 8/12. I'm going to divide it by 4, and because I do it to the top, I have to do it to the bottom. And 8 divided by 4 is 2. 12 divided by 4 is 3. So I'm using my greatest common factor to find my equivalent factor. And they call it simplest form. The reason we call it simplest form is because there is no common factor that 3 and 2 both have in common other than 1. And if we divide by 1, we'll still end up with the same thing. So 2 and 3 don't have any common factors. So that means it's in simplest form. There's no number that you could factor out of both of them. All right, we are getting on to our problem sets. So as usual, they've done the first one for you. And this is more of just what we were doing yesterday. We put the shaded fraction into larger units and then express them. I'm going to do B for you. I want you to do this on your own. You come back and check it. But B is the one that I will do with you, and you'll do the others. Make sure that you follow along that you do those on your own. All right, I'm looking at B, and I can see that I'm starting off with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 12 units, so I know that's my denominator. Of those 12, 1, 2, 3, 4, 5, 6, 7, 8, 9 are shaded, so my original fraction is 9/12. I need to get that to another fraction. So I'm going to start with 9/12. I'm going to divide by something, so I'm looking at this and I see that I can easily put this into groups of 3. That works really nicely. So I'm going to divide by 3. And now I have groups of 3. 9 divided by 3 is 3. 12 divided by 3 is 4. And as I look at my model, I see, yes, that is what I have. I have 4 groups, which is my denominator, and 3 of those groups are shaded. So I have 3/4. You're going to follow that same process and do C and D here. And we're doing more of the same again on 2. You've got this same sort of thing happening. You're going to express the equivalent fractions in a number sentence using division. I want you to do these the same. I want you to do them on your own. And then you can come back and check and see if you agree with what I do. So pause your video, finish your project, your problem set, and then come back and just see. All right, I'm looking at B. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Once again, we have 12 parts. So that's my denominator, 12 altogether. 1, 2, 3, 4, 5, 6, 7, 8 are shaded, so I have 8/12. All right, I need to decompose these into, compose into larger units. I'm seeing that I can do 4 together, so that's what I'm going to do. And since I'm now putting groups of 4, I have to divide by 4. 8 divided by 4 is 2, and 12 divided by 4 is 3. So if I look, I can see, yes, I do have 3 larger units. 2 of those are shaded, so I can see that I'm correct there. On number 3, you're going to draw an area model to represent each number sentence below. And so we're going to do what we've just been doing. They've given us kind of the answer that we've had before, and now we're going to go ahead and draw a model to match that. So I want you to do these on your own and then come back. All right, I'm going to look at 3A. I've got 4/10. So I think I'm going to go this way. I'm going to divide into 5 first, and then now I can divide into tenths. And I have 4 of those shaded. Okay, 4 of my 10. And now I have to compose them into a larger unit. Now you probably don't have the advantage maybe of having different colors there, but make sure you just, I'm going to put 2 together because I know that 2 is going to work for both of these. I could try doing 4, but if I do 4, it doesn't work. I don't have an even 4. So now I have 1, 2 shaded of my 1, 2, 3, 4, 5. All right. Is this all making sense and pretty straightforward for you? This next one we're doing 6/9. So I think I'll do 3 and 3. And I've got 6/9 are shaded, okay? 6 of my 9. But now I can see, since it's in 3s, I can see, oh, I can easily put these into groups of 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, which is what it's showing me right here. I divided by 3, and now I have 1, 2, which is our 2 out of my 3 groups, so 2/3 right there. Alrighty, on this last one, we are going to use division to rename. So we're going to try and use the largest common factor of these. So if I look at 4, my factors here, I want you to do these on your own first, then come back. Again, always try and do this on your own, then come back and check. I know my factors of 4 are 1 times 4 and 2 times 2. So they're 1, 2, and 4. I know my factors of 8 are 1, 2, and 4, and then also 8. 1 times 8 and 2 times 4. If I look, I see that 4 is my largest common factor. So I'm going to start with 4/8. Because 4 is my largest common factor, I'm going to divide by 4, and I end up with 1/2. Now you have the option, you can use division. If you need a model, you can draw a model to help you. But try and use the largest common factor if you can. Let's look at B. And I think we'll draw a model and we'll use the largest common factor on this one. So I'm first going to draw a model. So it's 16. So I know that I need to draw 4 by 4. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I've got 16. I'm going to shade 12 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, I can see that I can put those into groups of 4. And so if I'm just using my area model, I can just do that. I can just do groups of 4. All right. So because I did groups of 4, then that means I'm going to start with my fraction that I started with. I'm dividing by 4 because I moved them into groups of 4. And then that's going to equal 12 divided by 4 is 3. 16 divided by 4 is 16. If I had used factors, then I know that my factors of 12 are 1, 12. We've done this so many times. 2, 6, 3, and 4. I know my factors of 16 are 1, 16, 2, 8, and 4 times 4. So when I'm looking for the largest common factor, I see I've got 4. So I'm going to divide by 4, which is just what we did up here. We divided by 4, and we got 3/4. All right, the rest of these I'm going to do using factors. You know how to use the models if you choose to. So 12/20. So I'm going to find my greatest common factors. So I need to find my factors of 12, and I need to find my factors of 20. Okay, factors of 12. We've done this so many times. We know 1, 2, 3, 4, 6, and 12. Factors of 20. Well, I know 1 times 20, 2 times 10, and I know that 4 times 5 is also equal to 20. So looking at this, I see, yes, we have a common factor 2. They both have a 2 right here, but they also both have a 4, and 4 is larger than 2, so I'm going to use 4. So I'm going to come up here, I'm going to rewrite 12/20. I'm going to divide by that greatest common factor, which was 4. And my new answer, 12 divided by 4, is 3. Whoops, that doesn't look very good. And 20 divided by 4 is 5. So there are my greater common factors. And there's my new fraction in simplest form right there. All right, we're going with 16/20. So we've already done the factors for 16. We know they are 1, 2, 4, 8, and 16. And we already did our factors for 20 because we did those above. 1, 2, 4, 5, 10, and 20. I'm going to change my color here just because I think it's a little confusing. So we're going to come up here. We're going to rewrite 16/20. We're going to divide by our greatest common factor, which is 4. For those of you that could hear that, that was Mr. Wright saying good morning. And then we're going to go ahead and do the division. So 16 divided by 4 is 4. 20 divided by 4 is 5, because that was our largest number that went into both of them. There was a factor of both of them. So 16/20 is equivalent to 4/5. And that is in simplest form. And that is we've renamed each fraction, given them an equivalent fraction. All right, we've come to the end of this. As you worked through these, you can now go ahead and go to your exit slip. Good luck with that. Have a good day.